Okay, so in the last video we set up a base class called employee and two subclasses or derived classes that extend or inherit from this employee class. So the way we set it up, the definition begins for a subclass or a derived class begins the same as any other. There's the pound if and def, and then you include any required libraries, and we saw that in the book they put in all of the usual things like IOStream, string, and so on, and it turns out we don't really need all of that stuff. Really all you need is the superclass.h file. So if hourly employee extends or inherits from the employee class, you sure do want to include employee.h, the .h file for the superclass. All of the other things, a lot of times you don't have to. They're sort of unnecessary. So if you look in employee.h, you will see that we can, unlike in the book, we can get away without actually including any of those things that the book includes. In this one, for the superclass, you don't need anything. Okay. Let's go back to hourly employee. All right. So you do need to include employee.h. If you really need to include libraries like string or IOStream, go ahead and do it, but a lot of times you can get away without it. Notice the heading. In Java, we would say some class X extends another class, but here we use the colon to mean inherits or extends. And we also use public inheritance, and we'll stick with public inheritance for the rest of the semester. I don't think we will run into the other kinds of inheritance. Okay. So the derived class only lists new or to be redefined members. So I think in the last video we were looking at this, and you might have noticed that you add a bunch of methods. I didn't actually point it out, but I should have, that in employee.h there's a whole bunch of methods that we inherit. So if you look at employee.h, all these things like get name, all these get methods, accessor methods, get name, social security, pay, and the corresponding set methods name, social security, and pay are in employee.h, and they're not redefined in hourly employee or salary employee.h. I didn't point that out, but and also notice that you have these data members, name, social security, and net pay. That's in the superclass employee, but of course, like in Java, you don't have to put them in the subclass or the derived class. So hourly employee, if you were to look at, for example, the print check method of hourly employee, you should see that it will have things like the name, get net pay, get social security number, and so on. You might think, well, can't the print check method of hourly employee just access these name, social security number, and pay data members directly? No, because as with Java, if you have a private data member in a superclass, as these things are, name, social security number, and pay, subclasses cannot access it. The subclasses would be able to access it if you had made this protected. So it's the same rules as in Java. So if you want to review the Java rules, it's pretty much the same, except it's simpler in that there is no default visibility in C++. You have to have everything. Well, actually, everything is, if you don't mention it, it is private. So there is, and I guess I would say it's more accurate to say that in C++, classes have the default visibility is private, whereas in Java, the default, if you don't say, is package public. So it's slightly different. Java and C++ doesn't have that fourth kind of visibility. Okay. So the derived classes only list new things. all of the things are already defined in the superclass or base class. All employees have, for example, social security number, name, and net pay. Hourly employee, that class adds constructors, wage rate, get rate, set hours. So let me bring up the code. Here's our employee and hourly employee has set rate, set hours, get hours, and constructor, its own constructor. I added a destructor. Actually, we don't really need this. It doesn't really do anything. It's empty. So it's just like not specifying one because you get a default one. And in addition to the data members from the superclass, this hourly employee adds 2 data members, wage rate and hours. Okay, so there's wage rate, hours are the member variables that the hourly employee adds in addition to what it gets from employee. Hourly employee also redefines or has a print check member function that overrides the print check function from the employee class. The employee class has sort of like a fake one that says shouldn't be calling this and it exits. If you remember that from the last video. So take a quick look at that. Employee has a print check that says print check function called, this shouldn't call this, and it exits. Whereas hourly employee has a real one in which you print out a check. So pay to the order of, get name, sum of total pay, and so on. Okay, so the hourly employee print check is meant to be used. The employee print check should not be used. If it happens to be used, it'll print out an error message and quit. So therefore, this print check function should override the print check function that this class inherits from the employee class. The definition must be in hourly employee class's implementation, that is in the .cpp file. So as do other member functions declared in hourly employees interface. Typically, you want to put all your method bodies in the .cpp file as much as possible. There might be some good reasons not to sometimes, but most of the time you want to put everything in the .cpp, there's method bodies. Okay, so there's some terminology that you want to get used to. This is maybe a little bit different. There are some similarities with Java. So it's common to sort of use family relationship terms like parent class refers to the base class. That's also called superclass in Java. The child class refers to the derived class or the subclass. Parent is also called ancestor class because it's usually you might have many levels of inheritance, not just one level, or I guess 2 levels when you have employee and hourly employee. That's just 2 levels, and even though there's a salaried employee, that's just 2 levels. In general, you might have 3 or more levels, and so instead of just saying parent, we might say ancestor class. That's a parent of a parent, for example. Descendant would be the opposite of ancestor, so it's children and children's children. Okay, so the base class constructors are not inherited in derived classes. So this is pretty much the same as in Java. Java, you have your base class or superclass constructors. You can call them from the subclass by using the super keyword in Java. But there's no such thing in C++. There is no super keyword in C++. So they can be invoked within the derived class constructor, and what we will do is we will use initializers. So for example, if you don't remember what they are, you use them in constructors. Can't see all of this. Oops. All right, there we go. So hourly employee constructor uses initializers, and here is where you can use the this is probably the best place. There are actually other places where you can use this, but this is the best place to use the constructor of the superclass. And this will get called first. Even if you change the order, this will get called before you initialize data members of this subclass or derived class. Okay, so you do not inherit the constructor of the base class, but you can call it. Base class constructor must initialize all base class members. Of course, it cannot. Base class constructors cannot initialize your derived class variables because they don't know what you're going to inherit. So everything that you inherit from the base class and the derived class, those should be initialized by the base class constructor. So therefore, you should always be sure to call the derived class. I mean, always call the base class constructor in the derived class. The first thing that you should do is, so if you look in the hourly employee class constructor, the first thing you should do is call the constructor of the base class. Same thing with an alternate constructor where you get all the parameters or the arguments. You should call the corresponding constructor of the base class using some of the things that you get. So if you get name, social security number, you should pass that on to the appropriate constructor of the base class. And then initialize your data members of the derived class. Okay, so here it is shown again. In this case, and actually in all of the constructors we have in this example, the actual method body of the constructor is empty. You don't have to put in anything. You don't have to put this comment either. Just put in there just to show you that these constructors are all pretty much empty because all of the initialization is handled in this initialization section. So you call the constructor of the superclass, you initialize your own data members, that is the data members of hourly employee, not inherited from the employee class. Everything in the employee, everything that you inherit from employee, you should have the employee class constructor initialize. Okay, so as before, this is just an initialization section which we've used before, and you can use the constructor of the superclass in the initialization section. So very nice thing to do because it just sort of does everything in the right order. So if for example you have data members like this that for whatever reason depend on some data members in the superclass, having this done first, which is what C++ will do, takes care of initializing this properly. Otherwise you might get things out of order. Okay, so the default version of the base class constructor is called, in this case, if you have, for example, a different kind of constructor with parameters, you could pass on parameters into the appropriate base class of the appropriate constructor of the base class. Okay, so you should always invoke one of the constructors of the base class. Derived class constructor should always invoke one constructor of the base class. If you do not do that, the default base class constructor is automatically called. So if you don't, for whatever reason, if you don't make a base class call explicitly, it's implicitly there. You don't have to do it, but it's always a good idea to do it yourself. So if you, for example, skip calling the constructor of the employee class in here, it's actually implicitly called in here. So it's like even if you don't put it in, it's done for you.